Hello, everyone. This is Dr. Jackson, and this will be the lecture for the material that is covered in Chapter 4, which looks at measures of dispersion. Now, the measures of dispersion basically will look at things like range, standard deviation, variance, so on and so forth. Now, rather than go over all of the objectives, what I want to do really quickly before I get into the lecture is talk to you about how this particular lecture is going to be broken up. I believe this lecture will end up being a three-part lecture. The first part will cover range and interquartile range, as well as computing the range and interquartile range. Then I will go into standard deviation and variance. That will be part 2. From there, the visualizing dispersion, box plots, and some of the stuff that comes after that, that may or may not be part of part 2 of this lecture. It depends on how long it takes me to get through part 2. But I have a feeling it'll most likely be about a 3-part lecture. So the reason why I'm doing this is so that you don't have to try and sit through a full hour-long lecture. Also, if there's a certain portion that maybe you get and there's another part that you don't understand and you need to go back over that part, I want to make sure that they're separated so you don't have to try and listen to or hunt the part down that you need. So you know that this will be broken up into 3 sections. So I think that'll be beneficial for you. Okay, so in this overall presentation, the overall lecture for Chapter 4, you will learn and look at measures of dispersion. So you're going to learn the basic concepts of these different types of measures of dispersion. So range, interquartile range, standard deviation. You'll learn the basic concepts. Then, of course, you'll learn how to compute those measures of dispersion, as well as how to interpret each of these measures of dispersion. So I would suggest if you don't have it handy, or if you don't have a pencil and paper or calculator and all that kind of stuff with you right now, I would suggest you pause and then go ahead and get that material ready so that you can practice some of this stuff as I go through it. Depending on how things go, I may be able to do a few practice problems in a completely separate presentation and separate video. So the practice problems and the things that I do here in this particular lecture will be what's on the screen, and it will be related to what is in the chapter, and again, what's in this lecture. Okay, so measures of dispersion, or this concept or idea of dispersion. Some of you are probably hearing the term and you're like, what does this mean? I don't really get this. Maybe you've already gone through the lesson and some of it didn't quite click for you, or maybe you read through the lecture, and not the lecture, but the chapter, and you're still kind of wondering what measures of dispersion, what that is. Well, what measures of dispersion do? They tell us about the variety and the diversity of the sources in a distribution. The dispersion tells us information about how close or how far apart the scores are. In other words, it tells us how much variation there is in the scores. And remember, variation, pretty much it's talking about variety, if you will. How much do these scores vary? Okay. Additionally, measures of dispersion show how the data is spread around the central value, which is typically the mean. So simply put, it shows us how squeezed in or scattered the variable is, how squeezed in those scores are, how closely squeezed in and how close they are to the mean versus how far apart and how spread out they are from the mean. Now, sometimes the measures of central tendency for different distributions won't provide information about the differences among those distributions. So measures of dispersion can tell us about some of those main differences, okay? So let me say that again in case you got a little mixed up. When I say measures of central tendency, I'm talking about the stuff that we looked at in previous chapters. So the mean, median, and mode. So sometimes those measures of central tendency, the mean, median, and mode for distribution, they don't really give us information about differences. We may have 2 separate distributions and they both have the same mean. And so you could look at them and say, okay, well, they have the same mean, they have the same average, they're about the same. But there may be some things going on within that distribution that demonstrates that there are more differences in there than what we can see. So, another, I guess, example would be, imagine that we want to know the effectiveness of two different juvenile drug abuse intervention programs. We could look at the mean time to dropout removal from the program for drug use and rule infraction. So let me say that again. Imagine that you are in your job. Some of you have jobs where you are working in juvenile probation. Some of you have jobs where you are working in a detention facility. You may be working in some form of law enforcement. But imagine within your job, you have a program, or you learn about a program that is related to juvenile drug use intervention. Maybe you know about two separate programs, and you want to know how effective those programs are. Well, we could look at the mean time. And when I say mean time, what's the average time to drop out or removal from the program due to drug use or rule infraction? Because basically, if someone is if they're in this drug use intervention program and they get removed from the program because they start using drugs, or they continue to use drugs, or there's a rule infraction, we want to know what's the average time in between, because that can tell us something about the effectiveness of the program. So it may be, if there's less time in between removal from the program for drug use infraction versus, when they first came in, if there's a smaller amount of time, we might say, well, this program isn't all that effective. But then it may be that we have these two programs and they both have the same score. Maybe they both have the same mean score. Now, or maybe the mean scores are really close. Then it becomes, well, what do we do? It becomes a question of, well, which one is really effective? Well, what we would then do is look at the variation in the scores for each program. Now, of course, we're not going to look at every single score, but what we can look at are measures of dispersion, and that's what we'll learn about in this particular chapter, okay? So what we would look at and try to determine is if the scores are spread out and further away from the mean, or are these scores more compact? Are they more squeezed in and closer to the mean? If the scores are spread out and further away from the mean, then there's more variation or dispersion. That might not be something that we want for something like this, okay? So despite similar mean scores, this program with more variation or dispersion in scores would be less effective in this particular situation. You want scores that, for this particular scenario, you would want scores that are closer to the mean, so that there's not a whole lot of variety and variation going on with this particular program. So in this instance, and this is something you're going to want to think about and remember, in this instance, if we have two mean scores that are the same, or if they're really close and similar, we would then take a look at the measure of dispersion. And if the measure of dispersion, in this instance, it would be standard deviation, which you'll learn about a little bit later. But if the measure of dispersion is further away from the mean score, there's more variety, and we wouldn't necessarily want that one, that particular program. Okay, so just, I guess, an example, with regards to the type of data that we would be looking at, typically a larger data set or something with more numbers is going to have more diversity, just because it's a larger data set. Now, consider the example that's on this slide. So states such as California, New York, and Florida are going to be more diverse than others because there's a larger number of people. More specifically, these larger states will have more diversity. Also, you can think about it in terms of cities. The city of Houston is going to have more diversity and variation in scores than, say, Conroe or Huntsville, which is, you go down I-45. For those of you that are in Texas, you know what I'm talking about. For those of you that don't live in Texas, my apologies. Sometimes I forget that We have students in different areas. But for those of you that don't live in Texas, let's say you took the city of Los Angeles. Okay, I think we all know the city of Los Angeles. We all know the city of New York and different places like that. So maybe you have Los Angeles or New York City, either one of those cities, whichever one you prefer. That city is going to have way more diversity and variation in the scores than, say, a city like Fresno, California. That's a city that's in the northern part of California. Or even if you want to think about a city that's even more familiar, even though maybe you're not from that particular state. Let's say you looked at Huntsville, Alabama, okay, or someplace like that. A smaller city is going to have less diversity and less variation than a larger city. Same thing with states. In this example, we look at California and New York versus Maine and Iowa, okay? All right, so when we're thinking about dispersion, sometimes one of the things that I have found that really helps, and you'll see this kind of play out later on, especially when I start talking about standard deviation. One of the things that I have found that helps is to look at and draw these things out in a chart. Look at them visually. That gives you an idea of what the dispersion is going to look like. So right here we have something where the scores may be closer to the mean. Okay. So again, we can also look at a visual representation of dispersion, and remember that measures of dispersion tell us information about how the data is spread around the mean. So in looking at this particular visual representation, we can determine that the scores are situated closer to the mean. And think about what I just said a few moments ago about dispersion, and variation with the scores. If they're closer to the mean, then there's less variation. If those scores are spread out, there's going to be more variation. So this is a situation where it looks like the scores are closer to the mean. Whereas this one, the scores are spread out, all right? So, in looking at this visual representation, we can determine that the scores are situated further from the mean. Again, remember that dispersion refers to the variety and the diversity in a distribution. So this means that dispersion tells us about the variation in the scores. And a distribution whose scores are closer to the mean will have less variety, whereas a distribution whose scores are further away from the mean will have more variety. So a distribution shows scores, a distribution that shows scores that are further away from the mean has more variation or dispersion. So the taller curve, whose scores are closer to the mean, has less dispersion, and the flatter curve, which is what you're looking at on the screen right now, whose scores are further away from the mean, has more dispersion. And something I want to say real quick, because I'm using the term diversity in the sample. One of the things to keep in mind, diversity is something more than just racial difference. Diversity is not just, do you have minority, you have people of color within your sample, or do you have people of color within whatever it is you're doing. Diversity can look at income. It can incorporate things like age, gender, sexual orientation. So, different things like that. So when I say diversity in this context, I'm talking about the variation within that distribution. Do you have the cases within that distribution? Are they all kind of the same? Are they, how much variation is there in those scores? All right, so just to give you another way to look at this, this is the two, I guess you could say the two charts, not charts, but the two graphs are visual representation of the scores overlaid, one on top of the other. And you can see the distinct difference between the two scores. They both have the same center. I believe on the previous slide, I'm going to go back a couple of slides, so bear with me. Oh, I only need to go back one. So, you know, in looking at this, you can see that the mean, it looks like the mean here is a 7. Uh-oh. Sorry about that. I was actually trying to write on the screen. You can see here that the mean is a 7. All right. So same thing here. The mean is 7. All right. But those scores are, the distribution of the scores are closer together versus when you come here, they're spread out. And if we have this same graph or same chart, let's say it was that same set of scores, the mean is still a 7, but in looking at the close dispersion, you can see that the scores that are going to be there are closer, all the scores are closer to the mean. Whereas for the wide dispersion, they're further out. And you'll see this, you'll really get to kind of see this when I start talking about standard deviations, okay? Now, one of the other things that I want to have you look at or talk to you about, excuse me, is central tendency and measures of dispersion. Now, there are going to be three different things that I talk about. And this particular chart, I want you to revisit this chart once I finish with this lecture. You know, maybe what I would suggest you do is maybe take a screenshot of this, write the information down, however it is that you take in information and retain it. I would suggest that you do that and keep this somewhere for you to study, because what this is giving you, it's giving you information about the different types of data. So, you know, for certain types of data sets that have certain types of variables, there are certain measures of central tendency that we would use, and there are certain measures of dispersion that we would use. So if you look all the way at the bottom, down here where it says nominal, so sorry, you guys. Okay. So down here where it says nominal, okay, remember that's one of those measures of central tendency, excuse me, it's not a measure. That's one of those levels of measurement, my apologies. That's a level of measurement. Remember, we had 3 different levels of measurement. Technically there are 4, but when I teach levels of measurement, I combine interval and ratio. But nominal, excuse me, nominal, that's the one where you don't really have any numerical value to the item. So things like gender, race, stuff like that. Well, what this table or this little chart is giving you, it's giving you an idea of the measure of central tendency. Because those nominal items don't really have a way for us to, they don't have a numerical value. We can't really use range, we can't use quartiles, and we can't use standard deviation. So we end up using mode. And then as you move upward, you'll see, depending on whatever's going on with the data, it gives you an idea of the measure of central tendency and then the measure of dispersion that you need to use. So I'm actually going to go ahead and stop right here. I thought that I would go all the way through range and interquartile range, but I'm going to stop here and then start part 2 at range, and then we'll go from there. So it may end up being that there are 4 parts, but these 4 parts to the lecture, if that's what ends up happening, they'll be a little shorter than if I did the through section. So I'm going to stop here, and I will pick things back up for range as part 2.